So, graphing linear functions. This is where we are graphing functions that have the form mx plus b. So we have some slope and some intercept, which we'll talk about those values more in a later video. In this video, we're going to focus on just graphing with 2 points, because really that's the minimum that we need in order to graph a line. If you have 2 coordinates, you just connect them with the straight line, and there you go. What'll make it even stronger though is having a 3rd point. You can use as to kind of confirm where you're landing. And then this line here is made up of all these different coordinates where each one is a solution to this linear equation here. All right, so let's try this out. We're gonna just look at creating a table of values and graphing some points. And we'll also look at finding the intercepts, because oftentimes those are kind of easiest to find. So we want to graph y equals 2x minus 1. And we want to do it by filling in a table and then plotting the coordinates. Now, making a table of values, I recommend grabbing some negative values, some positive values. How about let's go -3 up to +3. So this is going to find us lots of coordinates. Again, minimum we would need 2 in order to make the graph, but having more can just kind of confirm your work. So what we're doing here is we're plugging in order to calculate y, we would be taking 2 times our x coordinate minus 1. So if I plug in -3, that's a -6 minus 1, so that's a -7. If we plug in x equals -2, -4 minus 1, so -5. Plug in a -1, -2 minus 1, plug in 0, -1, 2 minus 1, 4 minus 1, 6 minus 1. All right, so we have a bunch of coordinates here. And let's see, -3, -7, we'll have that coordinate there. -2, -5, right there. -1, -3, 0, -1, 1, 1, 2, 3, and 3, 5. There we go. And what we should be able to do is put a ruler or straight edge of some sort on our paper and connect those dots perfectly with a straight line. And that'll continue on forever. Okay, so that's graphing with a table of values. Let's talk about x and y intercepts. So x-intercepts, this is where y equals 0. So we're gonna find our x-intercept. And then our y-intercept is going to come from where x equals 0. So then we'll find our y-intercept. So our equation 2x plus 3y equals 6. So finding the x-intercept, what we're going to do is plug in y equals 0. So we'll have 2x plus 3 times 0 equals 6. 3 times 0 just turns into 0, so we have 2x equals 6. Divide both sides by 2, so we'll have x equals 3. So we have a coordinate 3, 0. I'm going to do the same thing, but plugging in x equals 0. So 2 times 0 plus 3y equals 6. That'll leave me with just 3y equals 6. Divide both sides by 3, and y equals 2. So we also have the coordinate 0, 2. So in terms of solving, those are really nice, especially with plugging in zeros, because things often like wipe out because of that plugging in of a 0. So 3, 0, 0, 2, and then at minimum we have our 2 coordinates, and we could just connect those with a line. What is helpful is grabbing another coordinate just to check that we're on the right track there. So let's say we grab a 3rd point. Let's plug in, really we could choose any value for x. We just wouldn't want to use x equals 0 or x equals 3 because we have those 2 values. Let's let x equal 1 and just see what that does. So we'll have 2 times 1 plus 3y equals 6. So 2 plus 3y equals 6. 3y equals 6 minus 2 is 4. So y is equaling 4/3 or 1 1/3. So in terms of graphing, we're at 1, and then I would just have to do my best to estimate this. But if I imagine starting to connect this with a straight line, that point makes sense. We're not far off. If I was graphing and it was something like up here, then I would know I did something wrong in my work, because those 2 points should connect with a straight line, so anything in between should also be on that line. So with that, we just kind of confirm that we did this correctly, and we can just lengthen our line a bit and let it go up to infinity. So in terms of graphing linear functions, these are methods we could use, just plugging in values for x to get some coordinates out, or focusing on the x and y intercepts.